Okay, now it's recording. All right, in the first problem, they have the strangest idea ever. They have a ladder which has no friction. And this ladder that has no friction, and the only way I can picture a ladder that has no friction is some weirdo put wheels at the top and the bottom. All right, so this ladder has no friction. It does have some mass. They said that the mass of the ladder is 45 kilograms. They said that the length of the ladder is equal to 5.0 meters. That means that the center of mass of the ladder is at 2.5 meters, and so therefore I have this vector here, which I'm going to call the weight of the ladder, which is of course going to be the mass of the ladder times g. Then they say that they mentioned that this angle down here is 60 degrees. They said that they want to know, can an 80 kilogram person stand safely on the ladder 2 meters from the top? All right, so that's the person, P. So the mass of the person is equal to 80 kilograms. They are 2 meters from the top, 2.0 meters from the top. Let's see, without causing the ladder to slip, if a second person exerts a horizontal force of 500 newtons towards the wall at a point 3.5 meters from the top of the ladder. Now 3.5 meters from the top of the ladder is 1.5 meters up from the bottom. So that's about right here. 1.5 meters. And this is the applied force as far as I am concerned. And the applied force is equal to 500 newtons. Now, of course, we also have the weight of the guy here, the weight of the person on the ladder. We do have the mass of the person, so his weight is easy to figure out. All right. That's it. Okay, so the question is, will it hold? Okay, is the sum of the torques equal to 0? That's what we're trying to find out. First of all, there are two forces that are not introduced here. What are they? Find me a force that's not drawn in the picture. We got gravity. Everybody always goes for gravity first. What else? Normal. It's touching the floor. Okay? So we have a normal 1. Why did I say normal 1? Because it's also touching the wall. So we have a normal 2 here. Now, from the... if we make the assumption that it will be in equilibrium, then that means that the forces to the left and the forces to the right are equal in magnitude. So the applied force must be equal to normal 2. So that's also 500 newtons. And if we really wanted to, we could figure out N1. But I'm going to ignore N1 because I'm going to put my pivot right there for this analyzing if the torques add up to be 0. Guys, quiet in the peanut gallery. Yes, that'd be you guys. Alright, so we're trying to figure out if the sum of the torques is equal to 0. My first torque is this one. Now, before I can do torques, I gotta do angles. I gotta know that angle. I gotta know that angle. I gotta know that angle. And I gotta know, here's the hardest one, that angle. Alright, every angle that is from the direction outward, that's R, over to the various forces. Let's do the easiest one first. Right here, what's that going to be? 60. All right, now if that's 60, then if I were to draw 60 up here, how much more than 60 is this? Horizontal was 60 plus The difference between horizontal and vertical is 90, so 150. 150 degrees, and this one are the same. So those two are both 150. Now, up here, what is this inside angle at this point? 30. Okay, so if that's 30, then that's 30. And so up here, we've got 30 plus what? 90, so that one's a total of 120. Okay, we can find all the angles. All right, so here's the question. Is the sum of the torques equal to 0? That means the torque from the applied force. Now, I'm calling that one positive because it's going to make it rotate to the counter in the... Actually, I'm calling clockwise positive at the moment. Who cares? All right? If it's going to rotate, that's the direction we expect it to rotate. So, anything making it go to the right, I'm going to call positive. This would make it go to the right. That one's going to make it go to the right. That one's going to make it go to the right. Only that one's on the left. So that means the torque from the applied force plus the torque from the weight of the ladder plus the torque from the weight of the person minus the torque from the normal force against the wall. Now, in order to speed this up, I'm going to figure out what those weights are. So the weight of the person is the mass of the person times g. So that's 80 kilograms. You know what? I'm just going to go nice and easy and say 10. So it's 800. 800 kilograms roughly. That means that the weight of the ladder is roughly 450 kilograms. Now, should it be kilograms? Weight. No, weight should be newtons. Just mess that up. Newtons. Okay. All right. I'm going to need those over here. So, the sum of the torques from the torque created by the applied force is going to be the value of the applied force, 500 newtons, times the distance away, which is 1.5 meters, times the sine of 60 degrees. I'm going to add them up vertically because I don't have room horizontally. My second torque is the weight of the ladder, which we decided was 450 newtons, times the distance away from my pivot, which is half the length of the ladder, so 2.5. 2.5 meters, times the sine of the angle between my radial distance and my applied force. So that was 150 degrees. Plus the weight of the person, which we decided was 800 newtons, times the distance to the person. If he's 2 meters from the top, he's how far from the bottom? 3 meters. 3 meters times the sine of, again, 150 degrees, minus, this is the only negative one, the normal force. We decided the normal force had to be equal in magnitude to the applied force because everything else is vertical. So that's going to be 500 newtons times the full 5 meter length of the ladder times the sine of 120 degrees. All right. I'm going to get some I'm going to get some middle values over here. 500 times 1.5 times sine of 60 is 650 newtons. 450 times 2.5 times sine of 150 is 560, we'll say 3 newtons. 800 times 3 times sine of 150 is 1200 newtons, minus minus 500 times 5 times sine of 120, which is 2,165 newtons. Add those guys up. 650 plus 563 plus 1,200 minus 2,165, and we get 248 newtons positive. What the heck? These are not newtons, by the way. These are Newton meters, which are units of torque. Okay, so what does positive mean on my picture? Is it going to rotate? Yes. In which way is it going to rotate? The way that I called positive, which is which way? Clockwise. So this whole thing is coming tumbling down this way. So that applied force is not enough to hold it in place. This guy is going to go splat onto the ground. All right, that's the end of the problem. We could have done it from up here. If we did it from up here, we would have gotten an answer which was from his point of view also clockwise, because as this goes whomp, that's from his point of view, it's rotating clockwise. All right, that's the end. Thanks for watching.